So good morning, everyone. It's a real pleasure and honor to introduce and chair this session. My name is Michel Scoop. I'm from the European Commission, working on open science and especially on the European Open Science Cloud. So this session today is structured into two parts. We will first have 5 presentations of less than 10 minutes. That's a message to the speakers, because we are short of time. And it will be followed by a panel with many people, actually, to address 4 questions related to interoperability. So let me just introduce the concept. Can I have my slide, please? The concept for this workshop. Okay. So my starting point is coming from the European Strategy for Data. And it's an obvious statement for all of you, I guess. The value of data lies in its use and reuse. Sorry, I have to change my glasses because I cannot see the slide over there and I cannot read myself. Age is there progressively. So yes, that's much better. Just to frame this session, research data need to integrate with other data and interoperate with applications and workflows, being for analysis, for storage and processing. So regarding EOSC, of course, we all want to generate added value from the resources that will be shared through the EOSC Federation. And that's why interoperability plays a central role. And I would say not only interoperability, but also findability, accessibility, and reusability, so the FAIR concept. Of course, the research domain is known to be very dynamic and heterogeneous with many different stakeholders communities. Some of them have already developed disciplinary interoperability frameworks. And actually, they differ quite a lot from one discipline to another because there are different cultures. They use different types of data, different types of infrastructures. And it's also a question of structuring maturity level and dynamics. So all this might differ from one community to another one. And that's where comes the challenge for the EOSC, because we want to break down silos. And we want to be able to broker data services across borders and across disciplines. And that's where comes the concept of an interoperability framework for EOSC. Maybe a framework of frameworks, that's just a question from me to the panelists in the future, in the second part of this session, across domains, across communities, and across infrastructures. So I just took note of some milestones, starting with the birth of the FAIR principles that were discussed in 2014, 2015, including through Force 11, and then published by Wilkinson et al. In 2016. In 2018, the Commission did award a study on the cost of not having FAIR research data, and the estimation was about a cost of 10 billion a year for the EU alone. So we really better to be fair in the future. In November 2018, there was a final report by the EC expert group on FAIR data, and I'm happy that the chair of this group is in the audience and will participate in the panel. This was called Turning FAIR into Reality and Providing an Action Plan for the EOSC. We also launched, through the Research Data Alliance, a working group on FAIR data maturity model. The outcome in 2020 was a list of core assessment criteria for fairness and a classification of attributes, features that are essential, important, or nice to have. And then in February 2021, the previous EOSC governance did deliver an EOSC interoperability framework not really an operational framework, but let's say the general principles that should drive the creation of such a framework. And now I'm coming to a workshop that was organized last year under the Portuguese presidency of the EU, and out of which came a declaration on riding the next wave of research data, and especially in the context of leveraging the COVID-19 response towards advancing data interoperability. So this, this declaration started from the context. We were in the coronavirus crisis. There was strong pressure on the research community to speed up scientific discovery. And the response by the community was a really acceleration of the global collaboration and an increase in early and open sharing of knowledge, data, and tools. Hurdles were also identified. For instance, the ability to find and integrate different data types, such as virus and host genomics, clinical, epidemiological, and socio-economic data from different sources, from labs, from hospitals, from industrial settings, across countries, organizations, and communities. So we are not yet completely there where we want to be. And two prerequisites conditions were set for impactful science. And that's the end of my presentation. We have to be able to ride the next wave of data and to increase the volumes of relevant, fair, and open data and their reuse in multidisciplinary science. And this is something which was repeated as a priority in a meeting we had with the tripartite governance 2 days ago. There was also a call for a wide mobilization across the EU towards developing, in the context of EOSC, coherent interoperability frameworks that build on research community practices to enable interdisciplinary research and innovation. So the questions are, where are we now with respect to this context, and where will we be in, for instance, 3 years from now? So with this introduction, I'd like to call the first speaker, who is Mark van de Sande. If you can join me, please. So Mark is a technical specialist at SURF and the technical coordinator of EUDAT. Working in EOSC Future, you are a member of the Strategy and Oversight and Technical Coordination Board, and active in the architecture and interoperability activities. You was member of the EOSC Architecture Working Group, and currently in the EOSC Association Task Force on Interoperability between Data and Services, also involved in FAIRcore for EOSC. The floor is yours, and if you can be shorter than 10 minutes.
I hope.
You have the green button here.
Okay. Thank you. Good morning. Yeah, I think it was already described why we need the interoperability. And listening to the last days, I think it becomes even more, not just within EOSC, but if you look at how, for example, the data spaces are developing, then also there we need to expand also beyond EOSC to see what kind of interoperability is then needed. And we are basing our infrastructures on a federated infrastructure. And therefore, if you want to connect services, data to each other, but also across domains, then this interoperability becomes very important. Because if you want to make usable services, provide added value to the researchers so that they can use services and data across the domains, then this interoperability is key. And I think we also have to look beyond just what EOSC is able to provide. And I think if you look at, there are already many standards, and many communities already have adopted many different standards. But if you want to work across, then you have to see which of those standards can be used to bridge across. And then, therefore, I think just having a standard is not sufficient, but you need to know for which standard, in which context you want to use this standard to support interoperability across the different domains, but also across different kinds of data, but also different kinds of services. Therefore, I think for us, interoperability is really the key step to go to the next phase. What we are doing in EOSC Future is to facilitate the process to see, okay, how can you come to consensus to see which of the standards, which of the guidelines to use those standards to support the interoperability. We are defining this kind of process so that there is a governance structure of doing this. And it is not for us that we want to develop new standards. The only thing where we are looking more towards new standards of how do you want to connect to the EOSC core platform, how do you want to make use of those capabilities. But for connecting infrastructures, service and data to each other, this should be done on basis of what is already existing standards. But we need to know which of those standards do you want to promote through EOSC to support the interoperability. And for doing this, then we want to establish a governance structure so that you manage the process of finding consensus, but also that you come to a collective decision which of those standards should be promoted. And also we want to develop that in registry where those standards are being registered so that we can promote this to a broad audience within EOSC, but also beyond. I think another thing what we also want to do, next to having those standards and registry and coming to a consensus so that we promote those standards, we want to integrate this also, which of those standards are being used by, for example, the different kinds of services which are made available through EOSC, or which data sets can be used via which kind of standards. And this what we want to do is register this within the catalog so that you can easily search on basis of, I have this kind of data set, is this kind of data model, which kind of services can handle these kind of data sets. And if you can search on this kind of information, then I think you can already make a next step in interoperability. But still, the user needs to make use and select those kind of services and data to bring them together. This is a picture which we have been developing within EOSC Future to show that there are different kinds of interoperability and at different levels. For us, from the project point of view, we are more focusing to see what is the kind of interoperability with the EOSC core platform, how can you make use of those kind of functions which are listed at the bottom. But you also have the other kind of interoperability. But for selecting which kind of standards to be used or guidelines to be used to make those interoperability at the different levels, there you need the consensus across the different communities, across the e-infrastructures. We are not really looking into what the communities do by themselves, because they already have a long history of developing those standards, come to consensus what the standards to be used within the community, but more focusing on how you want to across different domains, different communities, but different levels of services. For this, we have been establishing a governance body for managing the process of selecting which kind of standards and guidelines to be used, to promote it through EOSC. That governance body has two different layers. One is so that you can provide and suggest which standards and guidelines to be used within the EOSC interoperability framework. There will be an assessment done to see, okay, is this guideline within the scope of EOSC? Is this of sufficient quality to be made available and promoted through EOSC? And then we have another layer of decision body, which is the advisory body, to endorse which standards to be included within the EOSC interoperability framework. And if you look at this at the moment within EOSC Future, the advisory body is the technical coordination board which we have. And the technical coordination board consists of representatives of the cluster communities, but also the infras. So that there really is a place where we can find this consensus to see, are these standards to be endorsed within the EOSC interoperability framework. At the moment, we are at the stage that we have the process available, we have the governance structure available, but more or less we are still need to populate the EOSC interoperability framework itself. So for this, we are looking into what are the standards and guidelines we want to use for the EOSC core platform, but we also want to support that communities, but also other kinds of stakeholders. We are developing guidelines and standards for different kinds of use cases, that they work with us to see how is the process for onboarding those standards in the EOSC interoperability framework itself. And for us, we started with monitoring, but we are extending this to other kinds of capabilities which we provide in the EOSC core. But it is also welcome that other communities, other stakeholders can come to us and see what is the process of how you can endorse those standards within the framework itself. This is the current timeline. We already had set up the definition of the governance. We had the consultation phase of the governance. There was somewhat confusing of what the current status of the EOSC interoperability framework was at that time, because we were focusing on how do you establish the governance structure. Well, there was some expectation that we had a full-fledged interoperability framework with all the standards included, but that we were not at that stage, and at the moment we are not yet at that stage. But at the moment we have the processes available so that we are able to populate the interoperability framework. Therefore, I want to invite everyone to see, okay, if you have standards for certain contexts, for certain use cases, come to us and we can go through the process to see how we can endorse those standards within the EOSC interoperability framework. Thank you.
Okay, thank you for this first presentation. The next speaker is Andy Goetz, who has been coordinating the Photon and Neutron Open Science Cloud PANOSC since 2019. Andy has been developing software since the mid-70s and has been active supporter of open source software and the development of open source software to benefit science and society throughout your career. So the floor is yours, Andy. Thank you.
You want to come down?
Yes.
Okay, I'll try and keep to the time or under the time. So yes, I'm going to present what's been done for the photon and neutron community. And we were presented or represented in the EOSC by two projects called PANOSC, which was the S3 institutes, and EXPANS, which was all of the national photon and neutron sources. So it's about, basically it's about between 15 and 20 facilities doing this. And I'm speaking on behalf of them. So interoperability is a large topic and has many different, of course it's also a tricky subject, very difficult, and I'm going to touch on it with some examples and also in different areas. So we have, and I'm speaking from the trenches, so I'm not trying to match up with what's been done with all the other efforts that are going on inside EOSC. I'm giving a point of view of what it's like when you work with scientists every day. So the problems that we're facing or the challenges as well. And what we've done to make interoperability better. So for data, first of all, I think really the take-home message here is, and this is something which has always been clear to me, is that to talk about interoperability between big domains like environment, social sciences, physical sciences, and that is very nice, but it's still very far from what's possible in many cases today. There'll be exceptions where we can do that, but in our case, at least in the case of the analytical facilities, I say we really have to learn how to walk before we can run. So most of the work we've done is to enable it for what you can do in people in the same scientific domain, because there's already a big challenge there, yeah, really. So we've done things like we've standardized and we've supported standardization of metadata, which is still not, or is probably never a finished topic, visualization, federation, and so on. And I'll show some of these examples. So as you might know, the PAN cluster, that's all of these facilities, we all produce basically petabytes of data, what is called raw data every year. And these petabytes, you can break them down into the data that comes directly off the detectors, the data that is then processed and is converted to some physical quantities, and then the results which result from that data analysis. And interoperability is working at all these three levels. So you have to make it work at all these levels. So one of the things we did, which is also maybe surprising to some of you, is just standardize how the different techniques are named. So the names of the different techniques. We have hundreds of different techniques. And if you want to search across all these techniques, you need a standard nomenclature, you need a standard ontology for that. And the work was done inside Expanse to do the so-called PAN-net, and this is a service which is now, the second step is to get this to be adopted by all of the people producing data and tag the data with these standard technique names. We're lucky in our domain is that since the 90s, we have a metadata standard called Nexus. It is, as I don't know what it's like in your communities, but in most communities, getting metadata standards accepted is a long, long process. So we have got, I'd say, good buy-in, but it's not finished. And it's a lot of work. But we've used these two projects also to support this, to say if we really want fair data, we must have a standard ontology. We must agree on that. And this is the one that is out there. So we did a lot of work in that. Just to give you an idea of how this works, partly is on the right-hand side, or on my right-hand side. You see the metadata tree, which has to be defined to be able to interpret the image which you see with these spots on it. This is an X-ray diffraction images, and convert that then to a molecular electron model. So you can see there's a lot of metadata which has to be gathered, agreed upon, standardized. Yeah? And this is the kind of work that people are doing in these communities since years. I mean, we didn't do it, but this is the kind of work that we have to make visible and make sure that it's used. And one of the ways we're doing that is also working with the publishers. So we're working with the International Union of Crystallography. We've helped them by developing validation tools which will validate that that previous said complex tree of metadata is correct for people who want to publish data. And I think this is something you can really, where you can improve things is by working with the publishers. We've also supported a standard binary format, and I think this is something which I don't see discussed a lot here. Also is that if we want to store this data for decades, and even longer than decades in some cases, the binary formats have to be, we must be sure that we're in control of them for all of this time. And I think the EOS could play a role there. So we've been working with this, there's one company that actually maintains the standard called the hierarchical data format, but which is widely used. And this is something which I think maybe the EOS could provide some kind of guarantee or some kind of support for this. I think you saw this yesterday maybe, but this is the Human Organ Atlas, which was one of the new results from the new source, and I can encourage you to go to the site. There's a new, in beta of course, but there's a new feature in there. If you click on the tab Reconstructions, you can look and zoom into someone's brain. A real, of course, the person was already, unfortunately, passed away before he came to synchrotron, but you can have a very interesting look into what the human brain looks like at the micron level. And the one thing that I wanted to bring this example up also is the amount of metadata you have to collect, because we're going into the final results, sort of, how do we share that with doctors now, with medical researchers? And this is something which has been done by the scientific team working on this, and they're getting a lot of medical researchers interested in this. But the tools and the data that is there, it still needs a lot of explanation for medical doctors. So it's not as easy as, even if you put it out there, you still need experts to help them understand this. Yeah? But it is already proving useful. One thing I just wanted to mention also was about COVID-19. All of these facilities had a program to support collecting data for COVID-19, and COVID-19 was going to, this data was used to determine the protein structure of the virus, to develop the vaccines, and also even to develop better masks. But when I look for where is this data that came from our facilities, and I looked on the COVID-19 portal, which is by EOS Life, I couldn't find the data from these facilities. I could find lots of other data, but the data from the photon and neutron facilities wasn't there. So one thing we've worked on is making a federated search available to make this kind of search possible across all of the data that's out there. So this is something which I think could also be enhanced inside the EOSC. We've also not only worked on data, but on services. So I don't know, I think it was about 4 years ago, there was the EGI conference here in Prague, where we said if the EOSC solved the AAI problem, it was worth it already. Yeah? So I'm just hoping the AAI problem is solved, but we should be much more ambitious than that. So we worked on AAI, data transfer, data processing, and all of these services really just have to work. You know, this is a slide from Steve Jobs. He said it must just work. Yeah? We shouldn't be fighting with these things still today, and that's why we made these things work for our scientists. The challenges which remain for us are continuously working on the whole metadata, because we have a very large diversity of samples, from humans to crocodiles to quantum dots to batteries to all sorts of things. And it's very hard to, not all of these samples have standard metadata. Yeah. I think making the tools easier to use from the cloud is very important, and working on the data search machines. I mean, we've done something which is already useful, but we're definitely not the experts in search machines. And I think there's a lot of knowledge out there which we still haven't been able to leverage. And you can go and look at the site over here called data.panos.eu and see if you find anything useful for your science. To conclude, I just say it's something which is still a huge job. I think it's the most difficult one. I think the F and the A are quite easy, at least if you have a policy. The I is the big challenge. And if you've got the first three, I think the R almost comes naturally. And yeah, so we're working, I think the thing that boosts really having good metadata is if you have automated data processing, because that relies on having the metadata available already. Working with the publishers and then making the data findable. Thank you, that's it.
Thank you, Andy. Very clear presentation and interesting messages we can address in the panel. The next speaker is Dr. Niklas Blomberg, who is the director of Elixir, the S3 research infrastructure for bioinformatics and life science data. Niklas has played an active role in forming the life science research infrastructure clusters, and the floor is yours, Niklas, please.
Thank you, Michel, and thanks for everyone who made it this morning. I realized there should be a map of Europe here. I chose a snazzy color and it washed out completely. So we're not, it's not fading into the background. So what I want to talk and describe is some of the work we've done in the life science cluster in connecting data across disciplines across Europe. I picked this title long before I saw Michel's introduction this morning, but I was pleased to see I'm bang on policy. But I hope what I wanted to do is just try to illustrate why I think interoperability is important and sort of the benefits and how we are addressing that to actually drive scientific use cases within the life sciences. So I'll start with an image that we made when we wrote the EOSC Life proposal. And so this is sort of images from all the different facilities from the research infrastructures in the life science clusters. And if you look at that, you realize that we are spanning as a group of facilities. So most of the infrastructures, of course, just like Andy just described, are providing experimental stations, experimental instruments, advanced instrumentations to scientists. And these sort of span scales from micrometer or sub-micrometer or even down to nanometers. So we have crystallography, electron microscopy, advanced light microscopy, up to actually ecosystem monitoring in the coastal stations from EMBRC. And also in terms of time scales, so many of these atomic experiments happen, of course, in the femtosecond time scales, and then you have things like the clinical trials or the large cohorts that sometimes follow people over the most of their lifetime. And so it's a very large set and very rich set of data that we're trying to. And of course, what we wanted to do when we wrote EOSC Life, we said, well, we want to find a collaborative space for digital biology, but really what we want to help the users to take their data and move that between these different facilities. So you should be able to come to, say, a coastal marine station, do sampling of ecosystems, look at some organisms, but you should be able to take those into advanced microscopy labs. You should be able to look at outcomes from clinical trials and then make use of some of the experimental facilities and mouse models, for instance. So there's been work harmonizing descriptions of phenotypes from mouse models and human trials and so on. So that's really what we set out to do, was that interoperability, the ability for sort of to help users to move along the experimental journey. And of course, to do that, we put in place a set of services. We said there were a couple of principles. We wanted to help the facilities to publish their data, to make sure that that data can be available in EOSC. And we wanted to help, just like most other scientific community, we have a very active set of software developers. A lot of the innovative science is sort of manifested in new software. And we wanted to help those to make sure they could move that software stack to develop their tools and make that available within the European Open Science Cloud, because that's really how we get the scientists in there. And so we started on this, and then COVID came along. And actually, it turned out that the sort of package of services, and you see some of the logos of the different services here, the package of services that we had put in place was actually really, really effective. And so that was what we then rolled over and used to drive the sort of data incorporation in the COVID-19 data portal. And that's really work that's happening in this new project called By COVID, which is also funded under EOSC. It was the emergency funding part of Horizon Europe. But really what we're trying to do is very much the same thing as we were setting out to do in EOSC Life. We're trying to mobilize data, in this case not only from research infrastructures, but then from a large number of different institutes and research centers across Europe, and also from sort of public health institutes. So FIRI is an emerging infrastructure for public health information. We wanted to connect that, of course, so you could do something interesting with it, standardize, and we put standardization after connection, and I'll come to that. I think the sort of interdisciplinary interoperability is actually very, very hard, and you can do a lot of things just by finding the data and then drive that in individual scientific use cases through connectivity. And then we wanted to expose and analyze that, and so we're using platforms like Galaxy, and we heard yesterday on Euroscience Gateway, which is now taking some of this stack and really scaling that up to many different scientific fields. So I think that's a really interesting development. And so why are we doing this? So why is interoperability sort of important to mobilize, connect, standardize? So this is an example from a work done by a group in Luxembourg with a network of scientists all over Europe. It's about 50 different groups contributing to this. But the idea is to bring in as much sort of biological data as possible and be able to connect that into what they call a disease map. But really what it is about understanding your experimental data or other people's experimental data in the context of the whole cellular environment. And so you are able to then to drill down and look at different cellular pathways, how drugs interact with different compounds and so on. So that's really interoperability. Within life sciences, it's the interoperability in practice. So I think this is a really nice example. If we then go across disciplines, and this is really hot off the press. So this is working by COVID, led by Henning Herm-Jakob, who is actually in FAIR's Fair, and he's here. And Marie Klemola from CESTA. And so this is a work to try to contextually link social science and humanities data with the molecular and the life science data in the COVID-19 data portal, which is quite hard to make that meaningfully searchable, because what it means is that you have to have a lot of Excel spreadsheets where you make assumptions on term equivalence and how you then map that into a search tool. And so it's taken about a year to get the CESTA catalog effectively indexed into the COVID-19 data portal. But I think it's really interesting, and so now when you start to search across all of the data, say for vaccination, you start to see both cohorts, molecular studies, resistance studies, but also the social questionnaires when it's looking at socio-economic drivers of vaccination rates and so on. So you can find all of that data in one place, which I think is really, really nice. So, so how do you do that? Well we have, I think the only way to forward is to really promote and use the value of databases and standards and oh, I'm missing a slide. So promote the use of databases, standards, and policies. And actually within we have settled on fair sharing as the major index, and this is where we build catalog after catalog after catalog. And so we can use the same infrastructure to again and again and again, which I think drives sustainability, but it also drives familiarity for the users. When they are coming back in a slightly different context, they understand how to work with that. And actually now we have taken all this stack into a new project called EOSC for Cancer, and you will recognize the colors are different, the graphics are different, but the sort of workflow is remarkably similar to what we've done in COVID-19. It's about mobilizing data from a host of different centers and then try to publish that, in this case, in some of the established cancer analysis portals, because that's where the users sit. And then try to be able to, if you standardize it well, you can then link in artificial intelligence tools and digital twins and so on. And that's, of course, is then linking with the cancer mission and other things. So when you do this, and I just want to highlight, then you have a whole set of new standards because this is touching healthcare. And so within EOSC Life, there's been work with the medical infrastructures to try to understand how we should best approach that sort of emerging standardization within that space. So just a couple of comments from me on the way forward, and I'll hopefully finish on time, Michel. So I think this wouldn't not be possible if we hadn't had this disciplinary data resources and catalog. It's the strength of these catalog, and the CESTA integration, I think, is testament. If the work hasn't happened in social science and humanities to have a well-indexed catalog, it would be impossible to cross-index. And so it's really important that we invest in these disciplinary data resources. And of course, that doesn't happen by chance. It happens because there is good research data management to feed data into these catalogs. So I think that it's really that first mile that determines what we can do afterwards. The third bit, I mean, the meaningful interdisciplinary interoperability is really hard, and it's actually quite costly. And so I think one need to make sure that you focus on high-value use cases linked to, for instance, missions or large strategic drivers, or indeed individual research projects. But it is quite resource-intensive. And so interoperating everything with everything is not possible. We will need to do that meaningfully. We need to drive that through use cases. People. So I think everyone I talk to struggle with finding the right skill sets, and we need to find ways of training and retaining people. So that means that we also train people, but we need to look at sort of mobility and development and retention. How do we help people in this space to have meaningful careers so they stay within the European Open Science Cloud organizations? This is true for research infrastructure. I think is true for almost everyone. And actually, this goes beyond data. We talk about data and research data management, but it's all digital assets, softwares, workflows, standards, training materials, processes. All of that I think we need to maintain well. So thank you very much for your attention.
Thank you, Niklas. Very good. We are still on time, so that's great. The next speaker is Sofia Sotiropoulou, who is working as a senior research associate at the Institute of Electronic Structure and Laser of the Foundation for Research and Technology, HELAS. So you're a physicist by background, and I think I will straight away give you the floor because your full bio is available online. So Sofia, the floor is yours.
Thank you very much. So today I'm representing IRIS, the European Research Infrastructure for Heritage Science. And IRIS has recently entered the implementation phase to prepare the operation of IRIS-ERIC, the European Research Infrastructure for Heritage Science Consortium. and to position IRIS as a reference research infrastructure in the domain of heritage science in Europe, but also in global level. Heritage science is inherently an interdisciplinary domain of scientific studies on cultural and natural heritage, as it draws in many diverse disciplines from humanities, sciences, and engineering. And researchers from these diverse disciplines need to work together to exchange expertise and co-create new knowledge. Heritage science, sorry. Okay, so that's why I understand that interoperability is among the core values in heritage science. IRIS is also an intersectoral community incorporating research institutions, universities, museums, cultural institutions, conservation centers, cultural and creative industries, and the society. And so researchers, either access providers or users, need not just to exchange data and information, but to co-create new knowledge and values. So we mean interoperability as a necessity at several levels. First, among specialists in the same techniques, working with the same instruments. And in this case, we are speaking about the standard ways to keep metadata on instrumental setups, on experimental conditions, and the ways the data formats, metadata for all these analytical processes, but we mean interoperability also at the higher level among disciplines that are involved in heritage science, coming from either humanities or sciences, and there, in order to explore all the wealth of resources, interoperability of data and semantic interoperability is a need. IRIS counts now more than 20 years of common developments through several research projects, but also gaining resources from parallel national and external EU-funded projects that all these years we have built synergies with them. So to fulfill our mission to provide access to cutting-edge instruments and services for a cross-disciplinary community of researchers, we have built a long and expandable catalog of services that is organized in 3 platforms operating now at present through the framework of Hyperion HS. And this is FixLab, giving access to large-scale and advanced laboratory facilities. It is MoLab, giving access to advanced mobile instruments and prototypes for in situ diagnostics, and ArcLab, giving access to scientific archives, either physical or digital, for heritage science. The new platform is DigiLab, still at its conceptual level, but designed to integrate data, digital tools, and services for heritage science, but also to host a virtual research environment for and cross-disciplinary environment for research. So we are working actually on the integration of all the 4 platforms, and the 4th platform, DigiLab, is designed to provide services for gluing all the other 3 operating platforms together to develop object-centered research. So why interoperability is in focus for us, as we see interoperability as the driving force to achieve our ambition for an integrated access to heritage science research services and to heritage knowledge. And building a gateway as a single entry point to discover all resources and research outputs for heritage objects as part of EOSC. So the current developments to improve interoperability, the work that is in progress is in the framework of Hyperion interoperability task and beyond, and our approach is a practical approach based on open formats and tools to share agreed model schemas, including critical metadata and documenting heritage science data life cycle as a whole. So this modeling of data creation processes and capturing metadata is first to draw workflow models based on concrete examples and common processes patterns of the different categories of services, and also the systematic gathering of information on how data is produced and managed at each of the data cycle stages, from acquisition to processing and finally publication. So where we stand today towards EOSC and the European Collaborative Cloud for Cultural Heritage, we are producing high-quality data, but that are, however, stored in local servers. We are proud of our scientific excellence, and we are working hard on the documentation of analytical protocols as workflows, and on domain and method-specific metadata schemas. Also, we are developing a semantic thinking, enabling the interdisciplinary, the cross-disciplinary interpretation of data. What are the challenges? Digital tools, services, and expertise is still in our community at a very elementary level. We need to learn from others. A lot of work is done manually in terms of digital work, and our challenge is to adopt existing standards and tools to be adapted and customized to the heritage science community specifics. So we are building also collaboration with other communities and groups to help us and on the digital tools to fulfill our mission and achieve our ambition. Thank you very much.
So thank you, Sophia, for this overview of what's happening in the cultural heritage community. Now I would like to invite the 4 speakers to join these very comfortable seats. Please come on the platform. And I'd like to invite 4 additional panelists to join as well now. And I'm going to introduce them one by one. Just a question to Sarah. Will there be a slide with the 4 questions? Yeah. Yes. Okay, great. Thank you. So I think we had a nice introduction with testimonies on what's happening in various communities, cultural heritage, photonics, life science, also some introduction of what's happening with EOSC Future. And now we now have a set of questions that we would like to address till 10:30. Let me first introduce the additional panelists. So we have also in this panel Dan Broder. Hello, Dan. You're coming and representing the Fair Digital Objects initiative, the FDO, the Framework for Digital Objects. You have a background in electrical engineering and signal analysis, and you are currently involved in FAIR Core for EOSC and EOSC Future projects. You have also been a responsible convener for ISO standards on metadata and persistent identifiers. So all very interesting, good work that we would like to see also connected to the EOSC context. We also have Ingrid Dillo with us. Sorry, So Ingrid is the coordinator of the FAIR Impact Project. You have been coordinating in the past the FAIR is Fair support action. So you are really deep into the verification process in the EOSC context. We also have Simon Hudson, who coordinates the World Fair New project. You are the executive director of CODATA, the Committee on Data of the International Science Council. You have been chairing the expert group on fair data, which I was referring to in my introduction, working also in the UNESCO context on open science. So I really thank you for joining this panel all, and I'd like to show the questions now that we would like to address. So the first one is about cross-domain interoperability use cases. As I said in my introduction, EOSC would like to give a push to address key societal questions, and this requires this multidisciplinary, interdisciplinary collaboration. I recall that Niklas mentioned that making everything interoperable to everything is extremely difficult, and that use cases might be a concrete way, driven by science, to act on things where this is needed, interoperability. So with this question, I'd like to first ask Sofia, if you agree, to give your perspective on this question. And you have microphones, yes, on the table. Thank you.
Thank you. Yes, I think that this question addresses directly the complexity of our community, of heritage science community. As we realize that within disciplines, interoperability is not that hard. That's a hard task. We are working on that, and we see that it is possible to work together. Scientists working in the same discipline with the same instruments, with the same techniques, are able to agree on common metadata, to document properly their protocols and to share data. However, at a cross-disciplinary level, things are not so easy. it is very hard to connect people working with very different techniques and very different approaches, and finally very different mentalities on the way they are approaching the same research object. So we reviewing the access services the last years, it comes out that, for example, in the different platforms of services there is a preference for each platform from certain disciplines. For example, Fixed Lab is more asked from archaeologists, geologists, and scientists, physical scientists, while MoLab is more asked for from conservators, art historians. ArcLab also is asked from the humanities sector and conservation more than from physical sciences. And so our effort in integrating all the platforms is harder, and we realized that we needed to work more on on interoperability in order to translate the research questions to analytical approaches and tools. We need to work more on semantics to reach this dialogue among the different disciplines. We need to work on the reasoning of the data creation processes in order to enable the tracing of the data production. And so we feel that we need much more interoperability work to reach this integration.
Mm-hmm. Thank you, Sofia. Maybe I can also direct this question to first Niklas and then to Simon. Before we move to the next question, we would be interested to know from the Elixir point of view, EOSC Live point of view, and the various clusters, what's the role to be played by use cases. And I think in World Fair as well, you have quite a lot of experience in working with specific communities and implementing fairness. So happy to listen to you both. First, Niklas, please.
So I think two important areas of cross-domain interoperability we haven't really touched on in any of the talks is connected with the environment and climate change. And so we haven't really talked about agricultural research and how the changing climate will impact you. I mean, there was a you could see in Economist this week, it's a large part of Europe will see up to 10-15% lower yields of most common crops. And I think this will be a strong driver for interoperability, connecting climate variables, but also social variables with biological data. The same will happen I think, in biodiversity. So there is some really beautiful research I've seen out of Spain, where they're trying to understand how, for instance, bats and other species that carry pathogens will change their habitats and areas driven by climate change. And so I think that intersection between the climate data and a lot of other data types will be really important for our society.
Mm-hmm.
Thank you. I think this is an important question. I'd like to compliment the three speakers on what I thought were three really interesting presentations. In particular from Andy saying that this is not easy, a lot of work is involved. And I also really agreed with what Niklas said about the need to prioritize certain use cases. You can't make all data fully interoperable across domains. So you need to prioritize certain use cases. But those use cases are manifold. And the pressing scientific challenges, human and scientific challenges, of our age, climate change and climate change adaptation, ecosystems, land management, agriculture, the growth of cities, etc., etc. All these areas are fundamentally cross-domain. In particular, they require data about the environment, about ecology, about biodiversity, but also they require the interaction of those data with human data, with social data, with health data, and with attitudinal information and data. So we can't address those issues without an interdisciplinary approach and without cross-domain data integration. Now, CODATA has been looking at this for a number of years. It actually goes back to 2013, 2014, when we ran a series of workshops on nanomaterials and looking at how nanomaterials were looked at from various different domains. Roll forward to 2017, 2018, we were asked by the International Science Council, our parent body, to address this issue of cross-domain research and cross-domain interoperability. We started that through a series of workshops, and that led to a direct collaboration with the Data Documentation Initiative, who, at the same time, were developing a specification called DDI-CDI. The CDI stands for Cross-Domain Integration. That development was a direct response to calls from the social science data community for a metadata specification which would assist data providers in combining social science data with data from other domains, in particular environmental data. We describe a number of use cases in a report we did for EOSC on applications of DDI-CDI. That was a collaboration, again, between CODATA and DDI. And it's being implemented in a number of example case studies. In particular, I see Hilda's there. Maybe Hilda could... there's a EOS Future science project, which precisely is looking at the implementation of DDI-CDI and other specifications to combine social science data, survey data, with environmental data. And now in World Fair, we have an opportunity to pursue a number of other case studies in a range of different domains. Some very quick examples. One project is Inspire, which is a population health project in Eastern and Southern Africa. Now, they take population survey data, population health data, and combine it with clinical outcome data, and now, with the COVID pandemic, with phylogenetic tree data. And from Nicholas's presentation, there's very similar work being done in Europe, so we should compare notes about that. But in that, there is a process analogous of working on the terminologies, implementing OMOP, and implementing DDI-CDI. Another example from World Fair is disaster risk reduction, and the collaboration between disaster risk reduction and a case study from oceanography. So you have a tsunami, you map that with oceanography data, you have to model it, and then when it hits, or in advance of it hitting, you need to have a model which allows you to quantify the cost, the economic and human cost of that disaster. And there again, I think you have a clear, pressing example of why we need to work across domains with built environment data, with assets data, with human population data, et cetera, et cetera. I could go on for a long, long time. I'm sure Michelle doesn't want me to, but there are manifold examples of this. And many of them are very important, pressing research areas, precisely as Nicholas said. So we do need to put in those hard miles, that hard work for preparing high-value data for those precise sort of research questions.
Can I respond to that?
Quickly, please. Yes, of course. Please, Dan.
Yeah, respond to that. Not so eloquent as you. I will try. So the key messages here are it's hard work, right? We cannot make everything interoperable with everything. That's clear. And it seems that topic-oriented interoperability, we think that's within our possibilities, right? I would say that yes, but what we also have to do, we have to save the existing and current efforts with respect to semantic especially semantic interoperability. So lots of the work that's being done with semantic interoperability is invisible, it's dark, and we should bring that to into the light so that people can use that as a basis to develop their, let's say, the interoperability that they need for other topics or maybe the same topic. Sharing these efforts is extremely important, I think.
He was just going to comment on the same point, so thank you, Dan, because there is an interest by the EOSC governance in general to develop a catalog of best practices and use cases in the future. So this is also a wish from my side to see these various projects running use cases to really interact with notably the European Commission so that we can include some of those use cases when they are mature enough and completed so that we can expose them further in the EOS context.
Tomorrow in the semantic interoperability session, we will show some semantic infrastructures that will be built by the FAIR Core for EOS project that can be helpful too in that respect.
Very good. And I think also all this links also to a European and even international policy agenda. When we think about the sustainable development goals, I think we are exactly there speaking about use cases to solve societal issues that are cross-disciplinary. Okay, I will not be able to give the floor to all the speakers on all the questions because we are short of time. So I'm now moving to question number 2. Where are we standing with respect to generating data that are fair by design? And what role could European research infrastructure play with this respect? This is a very big issue. I mean, fair by design is attracting a lot of interest by the member states. We are discussing this in policy papers in the EOSC steering board. And we believe that with the expansion of volumes and diversity of data, better to make them fair as early as possible in the process and ideally at the generation acquisition stage. So for this question, I'd like to give the floor in the following order to Andy, to Ingrid, and to Dan. So, Andy, could you give us your perspective on this question?
Okay, I'll be short. I'll try and be short, but as a representative of research infrastructures, this is really, I think, part of our mission. It wasn't part of our mission, let's say, 30 years ago, but I see this now as part of the role. I think Caro said that yesterday as well. Part of the role of the data producers is to make sure the data is fair as much as possible already at the source. And so what we are doing, and I think the way to do that is what's essential is to have a data policy. So this was, I think 5 years ago, wasn't as common as it is today, but you still see facilities that don't have a data policy. But with a fair data policy, which is there are now frameworks out there for knowing what to put into a fair data policy, I think you can solve the accessible part without any too much problems, because before people come to the facility, they have to agree to that policy. So that makes the data available after at least a minimum period of time. Or then the findable part is, we saw the search machines there. Already giving it a DOI as part of your data policy will make it findable. So the interoperable one is the difficult one. But I think we've heard all these experts here, and we've seen the efforts that are going on. We have to just keep on working on that, and it is the role of the communities, of course, to define these, what are the ontologies or what is the important metadata to have. But if the facilities like the RIs insist on this and support these initiatives, I think the I can be achieved up to a certain level, at least within the same domain. And for me, the R happens once you've got the first 3 letters. Because if the data is under a clear license, it's accessible, it's well described, the metadata is in a standard format, I don't see why you can't reuse it. So That's what I would say.
Thank you. Ingrid.
Thank you. Yeah, fair by design. So this is really about the automatic production of fair data. And I think that is, of course, the ideal world that we are all striving for here together. And I think that is, would be a very important end result, just as the concept of defining fair data, that concept as completely machine actionable units, also a wonderful thing. But I also think that we need to realize that we still have a very long way to go. Of course, the examples that we heard here today are wonderful, but we also need to realize that they are really at the front end of developments. So yesterday already there was a little bit of talk around the survey that has been done to get an idea of the fair status of the European research data landscape. And I just want to give you a couple of numbers so that we also know what the reality at the moment is. And that reality is that still 40% of the researchers don't ever share their data, store their data in repositories. That 40% have never heard of FAIR. Now, that might not be a problem, you could say, if they haven't heard of the concept, as long as they apply fair practices. But then 17% of researchers only say that they publish data with a license. 19% acquire a PID. And I can go on and on. So I think that it is very important that we are inclusive, that we see FAIR as a continuum with FAIR by design and machine actionable units at the very end of that continuum. We need to realize that there are differences between domains, but also in domains, between geographies. And I think that on that journey to FAIR, we have different starting points and we have different speeds. I think it's also important to realize that the issues that we're dealing with and the solutions that we need to look for are not only technical, but there is also a very important cultural element in that. And in the end, the idea would, to my mind, be that we are able to provide researchers locally in their own institutions with a set of practical and easy-to-use guidance and tools and services that really enable them to make their data fair. Looking at the experience that we have had in this FAIR's FAIR project, that was a generic project working on the implementation of FAIR for EOSC, it's very striking that the biggest successes of that project have been really down-to-earth practical outcomes, like a handbook for fair adoption in universities, a FAIR Aware tool that helps researchers and data experts to go through a list of questions to realize what they need to do at the start of their research to make their data fair right from the start. A fair data assessment tool for repositories to implement in their workflows. So all really quite down-to-earth bits and pieces. And of course, the challenge now is that we need to align all of these, to bring them together so that it's also possible to create a composition of services for researchers. And I think that that is the huge task that we are facing at the moment. And for that, I think that we need a broader, really operational interoperability framework that Mark was also talking about, and a compliance framework so that we can start that alignment right from the start. And I also think that the new European Horizon Europe projects that we have now have the opportunity to work closer together to make sure that we align all the practices, solutions that we will offer researchers right from the start and not have to face the fact that we need to bring them together later on. I think I'll stop at that.
Thank you.
Small remark.
Yes?
I can support what you said, Ingrid, about the awareness, also about trainings, I would say. And I think it's also important that we follow the FAIR principles in all this kind, and especially on elaborated sub-principles in the documents that was done in the past. For me, it's also very important that we have a clear view if we think about open research data. Openness of data is a very important aspect. It's also coupled with licenses, for sure. Open is not every time open. You have to clarify this, and you need a clear governance on that. So what I could realize in Switzerland, for example, we had a huge discussion about this yesterday, as we talked about what's going on with this fairness on different kind of discipline. So a lot of people are thinking in disciplinary silos. And the interdisciplinarity is not given per se, and you need to force the people to think about linked data. And this surprised me a lot, a bit, because we have VC3 elaborated and in place, and a lot of people knows about that. And I would say the aspects that helps us to solve or to make this efficient, we should go through real use cases. Real use cases, I would say, and Simon would probably mean the other way around, I'm using the word bottom-up. Probably this is the wrong one. But go to the researchers, ask the researchers what they would like to see, what they need for the research process. So facilitate the research process is a very important aspect. Thank you.
Very good. I'd like to give the floor to Dan, because I committed to give him the floor.
Yeah.
And then, I'm sorry, we will have to move to the next question.
So, fair by design, fair data by design, yes. I think it's a question of capturing sufficient metadata when you generate the data. But next to that, there is also the repositories, fair repositories by design. This is something that we really need. So repositories that are able to give all the fair information that's necessary, even require that, refuse the data if it's not fair. Have an API where you can get not only to the metadata, but guaranteed also to the data. That is a real problem. Have a suitable API for that. Fair digital objects, they have APIs that would offer a solution. Multiple are possible, of course. So think of the supporting technology for this also.
Thank you for this feedback on question 2. The next question is about standards. How do you see the role of EOSC in recommending domain-specific and cross-cutting data standards, while at the same time remaining flexible to adopt new and emerging standards? So this question I'd like to give it to Niklas, then Andy, and Ingrid. Niklas, would you be happy to start?
Happy to. So So there has been a lot of talk in EOSC about certification and adopting and standards. And I think I've said this before, but I do take a little bit of an issue with that. I think the role of EOSC is not one of picking winners. I think the role of EOSC is to set the rules of the game. And so I think EOSC can be very powerful in articulating both the importance and then are also articulating principles, even maybe maturation models that describes how these domain standards can move forward. It can also be very powerful illustrating the importance of these domain standards and then encourage funders to invest in the necessary work on developing these ontologies. I think Andy had a beautiful example of the work on the experimental ontology in the photon and neutron science. Those things aren't happening for free. So I think the role of EOSC really should be one of articulating fundamental principles, talking about how they can be published, and really trying to set the rules of the game rather than having sort of governance and certification and have insiders and outsiders.
Yeah, I would echo what Niklas said. I mean, to become a recommending standards is almost like becoming a standards body. And a standards body, I think, is a huge work, and you need also to have this kind of the expertise, the authority, and everything. And I don't see the EOSC playing that role. So I think, yes, we have to rely on the communities. We have to define rules, but I would also say, and there's one thing, a comment I want to make about, there's a danger that the EOSC stays within its own sphere and doesn't go out enough to the other actors in this whole scientific process. So one thing I see is, for instance, closer working with publishers. I think this is really important. This is where the science eventually ends up being made visible. And I think if we talk too much amongst EOSC projects, we have this feeling we're solving this problem, but we're actually not in contact with where science is really happening or being published. So I would also say, you know, the EOS should have a strong link to these other actors, identify them, and somehow facilitate the links between the communities and these actors. So this is something which I think we have to work on, and I do worry when I'm in these meetings that it's too EOSC and not enough looking at where are we. We're just a cog in this whole wheel. Yeah.
Yeah, when talking about domain-specific standards, I would say that it's not so much the EOSC that should play a pivotal role there. I would personally go back to my own institution, DANS, which is a long-term data repository. And I think repositories have also a role to play here. We as a repository have strong roots in the social science and humanities, and for us, it is really core to look at our designated community, our user community, and to follow what's going on there, what the developments are with respect to file formats, metadata schema, preferred software, etc., etc. That enables us to cater to the needs of the repository, of the community, and that also in itself makes us and keeps us relevant. So this concept and this approach, I think, is vital for repositories. And I think if you look on a European scale, to my mind, the research infrastructures, the domain-specific research infrastructures have a role to play there. They cover, of course, a large part of the scientific arena. Always also very important to remember that they don't cover everything, that there is a long tail of science, of course, that is not represented there. When it comes to cross-cutting data standards, well, that also leads back to, I think, to the first question. And here, of course, the story is less simple. The only thing I would like to add here is that also in the new project that we started in June in Fair Impact, we are very lucky to be working with a number of partners from different domains, and with them we will try to also gain experience and explore in use cases whether we can transfer and also adapt fair solutions from one domain to another. So there we will also looking at semantics and metadata crosswalks, etc., etc. So hopefully that also leads to cross-domain developments that we can make use of.
There was one reaction. Yes, please.
Yeah, I'd like to come in on this point. There is no FAIR without the widespread adoption of community standards. It's there in R3. And as we heard, it's fundamental to interoperability. And to be frank, it's fundamental to international science to have data standards and specifications and widely used terminologies and nomenclatures. So we need those. I do think, I mean, then this question, the sous-entendu, if you like, or the behind it, the logic is what is EOSC and which part of EOSC? Now, I would feel strongly that the domain infrastructures have an important role in adopting and implementing those standards, of course, and therefore in recommending their use and in recommending a focus on certain I mean, Nicholas said back winners. We need to try and encourage our communities to adopt fewer terminologies, to coalesce around certain terminologies, rather than each project making its own ontology and vocabulary itself, when they exist. All that work exists in an ecosystem of standards globally. Now, Andy mentioned IUCR, but they're not just a publisher. It's the International Union of Crystallography, and you know this. I mean, they have journals, but they also look after CIF, the crystallography information format. Organizations like that play a crucial role in the global development of specifications and standards and the adoption by particular communities. And it has to be said that IUCR, since its existence in 1956 or whenever, has played a blinder because they have developed that specification. They have a community which revolves around certain journals, and they have really developed the specifications and standards which has allowed that community to be extremely successful and interoperable in what it does. We need more of that. And I do think that EOS can play a role in encouraging, in recommending, and the adoption is very much with those infrastructures, of which we have represented here. Can play a very influential role by saying these things need to be developed on a global scale, but they need to be adopted here in EOSC. Otherwise, the vision of EOSC for the implementation of FAIR principles, for the advancement of open science, will not succeed.
Thank you, Simon. We could speak about this for hours. I think this is a very important subject, but thank you for the remark. As a chair, I have to check the clock, so I'd like to introduce the fourth and last question for this panel, which is about the EOSC interoperability framework. So the question is the following: what are the next steps to make this framework more operational and impactful amongst the research communities? And here I will change the rules of the game. I propose that everybody in the panel gives a statement about the next steps, and I propose to end with Mark, because you are currently developing this framework in the context of EOSC Future. So maybe we can start with Andy and follow the seats in the order and coming to you. Thank you. Andy.
I'll be a bit provocative and frank. We don't see the added value of the interoperability framework as the EOSC, the one that's been discussed. It's not finished. I know it's not finished, but for us, we don't see where it fits in with our already overfull agenda. So the next step is to convince us that there is added value in us adopting it.
So I don't think we should underestimate the importance of EOSC as an initiative in bringing together communities. And I think we saw on this panel Andy's ontology. I come back to that experimental data. The very same techniques were used in cultural heritage, and the same techniques are used in life science. I think that would be a wonderful piece of work within EOSC, is to bring together these experimentalists and think about how do we actually ontologize the metadata across the fields, because I bet there are a lot of synergies. And I think that's really something EOSC shouldn't underestimate, is the power it will have, because it's cross-disciplinary, to bring together communities and foster that sort of bottom-up alignment.
Yes, I think it was said several times today, and I will repeat that it is very important to work on use cases, on worked examples, and because this is the way to go. I think that the guidelines are not enough. Researchers need to follow examples of their discipline, but also it is very important to look around and realize that there are several examples that we can use from other domains that have similar, not identical, but similar approaches. So we can learn from the others. And I see also, this was said by Simon, I think we need to collaborate with EOSC. I see the role of research infrastructure as mediators between EOSC and the researchers to propose, to promote standards and the framework, and on the same time to have the support from EOSC framework to identify and to be aware of what is already existing, and we can use it.
Thank you. The EOSC interoperability framework is still a work in progress. It's very high level. I agree with what Sophia has just said about engaging with the communities, and with what Nicholas said about patterns among communities and data. One of the outputs from the World Fair project will be a cross-domain interoperability framework. A set of recommendations on it, we hope some detailed specifications. We like to say that everyone's data is like a snowflake. It's unique, and yet it still has 6 sides, or six points. You know, sometimes it's not as different as people think or make out. They imagine that our data is unique. There are patterns. There are analogies in the way that we deal with data and that we describe it across domains. And what the cross-domain interoperability framework, what we hope to do in that, and what we have started doing, is breaking it down by a set of functions that need to be addressed. We need to have the definitions of, whether we call them quantities or measurands or properties, the things that are being observed or measured or described. We need to have units. We need to have descriptions of data structure. We need to have more effective ways of passing on the provenance and the process information, etc., etc. But there is a discrete and useful list of those functions that we can make. And once we do that, the task of using data across domains becomes a lot easier. And I think we saw that implicitly or even explicitly in some of the presentations earlier. So I think we're on the right track. And I think with the case studies in World Fair, we can make a useful contribution to that discussion. And I'm sure there'll be other work in EOSC and in the infra-EOSC projects which can also contribute to that debate. But I remain convinced that that should be the focus of our interest if we want to have an interoperability framework that addresses cross-domain issues as well and can be genuinely adopted by research communities.
Yeah. Well, I think communities should certainly be invited to publish their standards, their community standards in the interoperability framework, especially if they think it makes sense for other communities, especially if they have horizontal services which they think are also useful for other communities and that rely on using those standards. Looking at Mark's presentation about having the interoperability guidelines, in fact, machine actionable, being able to function as a kind of brokering layer between services and data, yes, that would be wonderful, but it might be difficult to implement it with how the guidelines are currently seen. And I mean, there's nothing wrong with not doing that, with having the guidelines just being paper, or not paper, but electric paper, right? There's nothing wrong with that.
Yes, I can echo a lot of what has already been said, being almost at the end of the row, of course. I think we have seen some nice examples of bringing together communities. I think we've also seen that it is really, really hard. I know that also from the By COVID project, where we try to bring the life sciences and the social sciences together. The only thing I would like to add is that we need to make sure that we put the communities center stage, that we involve them in everything that we do to make it meaningful for them, that we make it easy to use, and that we also make sure that the researchers get the recognition they deserve for their work and their part in this. Because sometimes I think that we are talking a little bit too much from the perspective of the service provider.
Yes, a lot of things were said, exactly. So what we are doing in the task force, that's the point that I can represent. So everything is more or less mentioned in this case. We formulate as 3 questions, 3 research questions. The first one was, what aspects of interoperability are relevant, should be addressed on a bunch of ideas, what should be interoperability at the end, right? What does semantic interoperability means in practice? What can we give them some tools, some ideas, some hints, some standards, some mapping processes, pipelines that automates the process, right? And the third one is, what is missing, what should be addressed, and what could help us for evolving good practice. Good practice is very important, comes to the awareness to the research area also, helps the research area to understand better what we mean with abstract concepts and standards. Standardizing something costs a lot of time, means we should shorten this and give them some good practice to help them to facilitate the research process. And I think this is very important. And if we have this answer, if we can give you a landscape overview with a kind of analysis, and if you have this and you can go deeper inside about crosswalks, about standards, and finally about interoperability indicators, then I would say we would be able to give you recommendations on that. And this should be finally the goal. So we are working on 2 white papers. White paper 1 is the landscape overview, and white paper 2 is exactly the crosswalks and the interoperability indicators. Let's see what is the outcome at the end. I hope we can give you some recommendations also to the community. Thank you.
Thank you very much, Mark. I think this, maybe a reaction. You skipped your turn, so I, please. Yes, okay. Yes, please do.
Okay, I think, and I fully agree at the moment, if you look at what the current EOSC interoperability framework is, it is not useful, because it is an empty box. It has nothing. So it only can consist of that if communities can work with this and to see what kind of standards they have and how they can promote this in a broader sense. And I think that is also part of the interoperability framework, to see what are the standards the communities have, to see, okay, which you can promote across a broader community. Because I also think that there are many standards being developed because of unawareness. Maybe other standards are already available, but they were not aware of this. And I think what the EOSC interoperability framework can be is a channel to promote which standards are available, but also to see what kind of recommendations you can make to which standards for which context of usage of those standards. Therefore, I think only having a standard is not sufficient, but describe in which use cases do you want to use this standard, for which use case do you want to promote those standards. And then hopefully adoption will come, and therefore in the end better interoperability. But at the moment it is work in progress, and it will take a long time. It will not be finished by the end of the project, but it should grow. I think that is the important aspect.
Okay, with this good conclusions from your side, thank you very much. I'd like to come to an end for this session. I'd like to warmly thank all the panelists and presenters. I think we have had a nice tour of perspectives from different disciplines, and also on the state of play with respect to the development and next step of the framework in the EOSC context. A lot of work, of course, still to come in the future. We do not want to leave any community behind, so EOSC is also there to promote, as you said, Mark, to promote best practices and avoid reinventing the wheels. That's, of course, very important. I see there are 3 questions from the Slido, so I don't want to ignore them. I think 2 of them are related to the clusters. One is about how far the clusters are driving or not the building of the EOSC. And it's also about use cases, whether they really use and leverage on existing semantics. So maybe Andy or Niklas could comment on this. And there is a question about sharing experience with the global community. And that might be a question to Mark. So would you quickly address these points?
So I speak to, so maybe the thing to do is to put in a very shameless plug for the next session where a lot of this is going to be dissected in, perhaps not forensic, but quite a lot more detail.
Okay.
So I think that would be good questions to come back to at the end of next session.
Where will that be? In the same room?
Yes, it's on the screen actually. So
okay, perfect. So the answer will come in the next session.
Grab a coffee and come back.
Mark, do you want to comment on the experience sharing with the global community?
I think that is the important aspect, because sharing this information, what are the use cases, what are the adoptions, but also maybe the difficulties in certain adoptions of certain standards. Is important, because there you can expose but also learn from each other what you can best adopt. And in certain areas I think it is maybe more important to come together. For example, if you look at the AI, what is also mentioned as one of the cornerstones, that you want to solve this, and there having a broader adoption across all domains I think is important, next to what is domain specific. But also looking at the mentioning of subdomains, I think that is part of the discussion which you need to have within the domain, within the community yourself, so that you can bring those together. And I think therefore, for example, the cluster communities are very important as a vehicle to bring those communities together, to come to consensus what is to be adopted within our community, so that you do not have those kind of subdomains. But you need also to leave some flexibility so that you can evolve.
Great. So with this, I'd like to thank you all. I think we should give an applause to all the panelists. So there is much more to come, starting with the next session in this room. Thank you very much. Enjoy the coffee break.